Hello everybody and welcome to today's lesson on angles and arcs in circles. Today our objective is we will be able to use angles, arcs, chords, tangents and secants to investigate, verify and apply the properties of circles. And we will also be able to find angles and arc measures created by central angles, inscribed angles, and angles in the interior or exterior of a circle. As you can see, there's a lot of vocabulary that we first need to get familiar with, so let's get started. A central angle is an angle where the vertex of the angle is also the center of the circle. So if we look at our example here, if I created this angle APB, that is an angle where the vertex is at P. So angle APB is a central angle. And if I look at this angle and want to determine the measurement, I can see that it's less than a right angle. So I'm going to say this angle has a measurement of 80 degrees, and we will need that measurement later. And where the angle connects with the circle, it cuts out a piece of that circle, and that piece we call an arc. So an arc is a part of a circle, and sometimes we also call it intercepted arc. And there are two different types of arcs. We have minor arcs. Minor arcs are arcs that are less than halfway around the circle. And for example, this arc that goes from A to B is less than halfway around, as we can clearly see. And the way we write arcs, we use letters just like in segments where the arc starts and ends. And then instead of a straight line, we put a curvy line above it. And this arc AB is a minor arc. And the measurement of AB is 80 degrees. Arcs are measured in degrees and part of a whole circle, which is 360 degrees. And the measurement of this arc is 80 degrees, and that is the same as the measurement of that central angle that created this arc. So let's go ahead and note this down on our page already, because we're going to have other formulas as well. In the case of a central angle, the angle measurement is the same as the arc. Put a box around it, circle it, highlight it. This is an important formula that you need to remember. Alright, so now let's go back to our arcs. We talked about the minor arc, and then a major arc is an arc that is more than halfway around the circle. In order to make that clear, we usually use not only two letters, but we use three letters to denote the major arc. So in our example here, if we took an arc from A going the other way around, then it would go across C, continue going all the way back to B, and then we call this arc ACB. That makes it clear that it's a major arc, and the measurement of this arc will be 360, because the whole circle is 360 degrees, minus the 80 that we already figured out for arc AB. So 360 degrees minus 80 degrees is 280 degrees. A semicircle, and you have seen and heard the word semi before, and that means half. So a semicircle is halfway around the circle. And since it goes halfway, the two endpoints will actually be endpoints of a diameter, because remember, the diameter goes through the center, which is also the widest point of the circle, and really cuts that circle into two halves. So if we, for example, started from point A and went to the center P, but then continued going on the other side until we hit the circle again, and here we create point D. This is a diameter, and that cuts the circle into two semicircles. And the way we denote the semicircle, we have two different options. We can denote it with three letters. So we could say arc ABD. We could also say arc AD. Doesn't matter because it's a semicircle. It's right between a minor arc and a major arc. And the measurement of the semicircle arc ABD is half of a full circle, half of 360 degrees, which is 180 degrees. So if we know the length of arc AB, which is 80 degrees, and we also figured out the length of arc ABD, which is a semicircle, and that's 180 degrees, we can also make a statement about the length of arc BD, and that leads us to an important postulate, the arc addition postulate. Arcs next to each other add to make a longer arc. In our example, that means the measurement of arc DB plus the measurement of arc BA is equal to the measurement of the arc AD. And in numbers, that means 100 degrees plus 80 degrees is equal to 180 degrees. Are you ready for some examples? Yay! In this example, we're given quite a few things. Segment AB is a diameter of circle P. Arc AD is congruent to arc BE. Arc BF is congruent to arc DE. And the measurement of arc DE is 80 degrees. So let's first mark everything we're given in our diagram and then work through the problem. Arc AD is congruent to arc BE, so we're going to give these two a congruent mark, and arc BF is congruent to arc DE. These two are congruent, and we're also being told that the measurement of arc DE is 80 degrees. So this is 80 degrees, and if we know that this is 80 degrees, then we know that arc BF also has to be 80 degrees because it's congruent. So we already know the measurements of these two arcs. And since we have been told that AB is the diameter of that circle, we know that the arc that goes from AB is a semicircle. And what does that mean? A semicircle has a measurement of 180 degrees, and these three arcs, AD, DE, and EB, have to add up to those 180 degrees. That means we know, so we can figure out what AD and BE have to be because they are congruent. 180 minus 80 leaves us with 100. And the 100 have to be split up evenly between AD and BE. So arc AD is 50 degrees and arc BE is also 50 degrees. And if AB is a semicircle one way around, then obviously it's also a semicircle the other way around. And on that other side, that arc FB is 80 degrees, So how much is left for arc AF? 180 minus 80 leaves us with 100 degrees. So arc AF has to be 100 degrees. Alright, all this we figured out only from the given information. So now let's see what does the problem actually ask from us. We're supposed to determine whether the arc is a minor arc, major arc, or a semicircle, and then give the measure of that arc. First arc we are asked about is arc BE. Arc BE we have down here. That is 50 degrees. That makes it a minor arc. And the measurement is 50 degrees. And then we have arc BAE. See how that arc goes. It starts at B and goes to A first before it actually ends up going to E. Well, that is definitely a major arc. And what is going to be its measurement? We're taking the entire circle except for the piece of B to E, which is 50 degrees. So we're talking about 360 degrees minus 50 degrees. So that is 310 degrees. And then we were asked about arc FA. And arc FA we have already figured out before. Arc FA is 100 degrees. And it is a minor arc therefore, measuring 100 degrees. Next we're supposed to find arc ADB. Arc ADB we had found before because that is actually a semicircle. And semicircles always measure 180 degrees. Next we're looking for arc AE. Arc AE goes from A to E, and that is a minor arc, and the measurement is the addition of arcs AD and DE, so 50 degrees plus 80 degrees, which is 130 degrees. Next our arc FDB starts at F, goes to D before it actually goes to B, and that goes pretty much almost around the entire circle. So it's definitely a major arc, and the measurement is everything except for the arc FB that we found before, which is 80 degrees. So 360 degrees minus 80 degrees, and that is 280 degrees. And last but not least, we got arc DFB, starting at D, going to F, and then continuing on to B. So we have a major arc, and that major arc measures 360 less those two pieces DE and BE. So 360 degrees minus 80 degrees and minus 50 degrees. So that will give us 230 degrees. So now, to finish up this problem, let's also write down the measurements of our central angles, which, as we know, have to be the same as the measurements of the corresponding arcs. So we have 80 degrees for angle DPE and 80 degrees for angle FPB. We have 50 degrees for angle APD and 50 degrees for angle BPE. And we have, last but not least, 100 degrees for angle FPA. And also, just as a side note, you can see very clearly how, particularly in a circle, it is very important to name the angle with the three letters, the center always being also in the center of the three letters of our name, because we have many angles that have P as a vertex. And if you went ahead and added all these numbers of our central angles, what would you get? Of course, 360 degrees. Alright, you guys, so much for this. And now go ahead and watch the next part of the tutorial on inscribed angles.